My name is Ken Duda. I'm one of the company's founders. I'm currently the CTO. I also run the software team. I wanted to talk about a particular issue with software which is really near and dear to my heart, which is quality. Quality is the most important attribute of our products. Not one of the most important, it's the most important. And the reason why is really simple. When the network ain't working, ain't nothing working. It's got to stay up. It's got to work. And so we've taken the challenge of how to build a much higher quality network box, how to give customers a much better experience in our network. We've taken that challenge as our first priority from day one. How do you build network software that's fundamentally better? And I believe the answer has three parts. Quality comes from three places. It comes from culture, it comes from architecture, and it comes from testing. I'm going to talk about each of those three. And I love questions, by the way, so please interrupt with any questions. On the cultural side, what I mean by the culture is what's important to people when they come in each day. How do people think about their jobs? How does each person make decisions that support the overall company's objectives? And when it comes to the culture of quality, what it means is behaving every day and in every way like you mean it, like quality really is the most important thing. For example, do you give your executives bonuses for hitting a particular ship date? At Arista, nobody gets a bonus for hitting a ship date. Some of our competitors, sometimes they do. Say, well, come on. Sure, they give a bonus. You've got to encourage the engineers to go faster, right? So it's not really so bad, is it? Well, no one's going to intentionally ship products that don't work. But when there's that meeting, you're trying to figure out, can you pull the gun and let this thing out? You're going around the room, and there's 7 or 8 software managers, and the first 7 say, yep, my stuff's solid, it's ready to go, we can hit full QA now, we're going to be on target, no issues. And you're the 8th guy, and you know that it's really close. I mean, it mostly works. And yeah, there's a few unexplained test failures, and there's just one case you know about, but that never really happens in the field, right? And you start making excuses, and you say, I think we can do it. The pressure, do you really want to be the guy who stands up and says, sorry, my boss doesn't get his bonus because my group's not ready? Like, it's a disaster, right? So you don't do it. People make excuses, and they end up shipping things before they're ready. Whereas when I go to my boss, the CEO, and I say, Jayshree, you know, I told you I thought we could ship by early September. It's looking more like October. We're just seeing more failures in our automated test beds than we like to see. She says the same thing to me every time, which is, okay, we'll manage in the field. And I was explaining this to an executive at a major financial firm. And he's not really a networking person, more of on the business side. And he says, oh, I see. You're shifting income statement risk from our balance sheet to yours. I'm like, what? And then I realized what he said was really smart. That's exactly what we're doing. We're saying, we will delay the shipment of our software and our products until they're ready. And by doing so, maybe we don't make our numbers one quarter. We take that risk. And we take that risk to avoid putting our customers' networks at risk, because it's just too important to us that their networks actually really, really work. And so, well, why is that? Is there really a business reason for that? And it's kind of interesting. I feel like culturally, at the heart of it, it's not even really a business decision, at least not for me. For me, it's about, why am I doing this? Why did I start this company? Why do I come to work each day? I'd done well enough at previous companies. I could have retired before founding Arista. So what makes it worth it? And what makes it worth it to me is the pride of my switches deployed in some of the world's greatest networks, massive web companies, mainstream financial services, the big HPC centers. And I'm so proud that we make their networks better each day. And what I hate is messing up their network, because that's not why I'm here. I didn't found this company to build switches to mess up people's networks. And so if our switches are misbehaving and that's causing someone a problem, that wasn't supposed to happen. That's what I want to focus on and get that taken care of, because that's why we're doing this. That's why we're here. So I don't know what gives us the best stock value in 3 months or 12 months or 5 years. To me, that's not really the important thing. My assumption is we do a great job for our customers. The stock price ultimately takes care of itself. And so that's why we're doing this. Another example of the culture of quality is when a customer is having a problem, how does the organization react? The TAC engineer looks at the situation and says, I'm not sure the switch is supposed to be doing that. That doesn't look good to me. What do? Do they have to go through some complex escalation procedure, talk to their manager, who talks to an escalations manager, who talks to an engineering manager, and then they try to make a business decision about, okay, well, which customer is this? And how much did they buy last quarter, and how much we think they're going to buy next year, and what engineer do we need to come look at the problem, and what feature is that engineer on, is it critical for the next release, blah, 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 blah. Like, I think that's a completely false business trade-off. The right answer is, you give the TAC engineer the phone numbers of the technical leads in each of your areas, and when they think the product's misbehaving, they pick up their phone and they call the right person. No escalation procedure, no managers involved, no phony business decision to make. Because first, there's again the sort of the cultural reason, which is that quality is the most important thing. We need to live that every day, and this is part of it. If something's going wrong in the field, that's our priority. So it's partly for the cultural reason. But I actually believe that in the long run, the business case is actually pretty clear. If there's a problem in your code and it's impacting a customer, it doesn't actually matter what customer it is. In fact, you should thank your lucky stars that it's a relatively small customer who's relatively patient, because you know what? If you don't jump on that bug, even if it's the nicest, sort of easiest going, lowest key, smallest customer in the world, you should jump on that problem, because it's just a matter of time until whatever that problem is goes and bites one of your top 10 customers. And the fact that it's happened somewhere else is great luck. Take advantage of it. Go fix it there, get the maintenance release out, and then you're not going to have the problem at a massive scale. Whereas if you go through this false business trade-off, you end up delaying, not avoiding, the work of actually making your software work and hurting far more customers in the interim. So our tech leads have very clear instructions from me. When something's wrong in the field, go fix it, because it's more important than new products, it's more important than new features, it's more important than hitting dates. And I talked to account managers about this, and of course the salespeople, they need to close deals, right? They need the latest features and the latest platforms, they need it all yesterday. Except never sacrifice quality. I get that message from them loud and clear. They would rather apologize to the customer 100 times for missing the date than apologize even once for melting down the network. And so our account managers tell me they're prouder to represent Arista's products and happier representing our products than anything earlier in their career, because they can spend their time selling and not apologizing. So it really pays for itself. So the culture of quality is really the foundation. It's really the backbone of getting to a high quality product and a high quality experience. It's just living every day as behaving 100% consistent, that getting it right, getting it working is more important than features, more important than dates, more important than shipping new platforms. And that's what we do each day. On the architecture side, there are a bunch of things we've done architecturally to lead to higher quality software. The first was just starting with the right foundation. Pure Linux. Our competitors look at Linux and they say, oh, I get it. It's like VxWorks, but it's free. They miss the Unix architecture, the Unix philosophy, and the Unix community. When the first thing you do is take the kernel in and start hacking, hack out the whole network stack, hack in something else, you cut your connections to that community. You can no longer easily upgrade to the newest version of Linux. And you can no longer just take ordinary Linux software and run it on your switch. It has to be ported because the syscalls are subtly different and your environment's not really exactly quite Linux anymore. By taking pure Linux, we follow the first rule of the Unix philosophy, which is that when it comes to the kernel, if you don't touch it, you don't break it. So we keep our hands out and keep our code in user space processes where they're all individually restartable. The second thing we did architecturally is that we took the system database approach. There's a question, once you separate your code into lots of processes, how do you then coordinate those processes? And the obvious answer is, well, message passing. One process learns something, it tells another process, which does some computation and updates the third process, and so on. Message passing suffers from two really serious flaws. The first, is the restartability problem. If a process exits and restarts, how do you get that process caught back up with all the others? Maybe you can restart from a checkpoint and then replay a bunch of messages and get there eventually. And there are real systems that work that way, like journal metadata and file systems, or database redo logs and transactional database systems. But doing that in every single one of your agents or your user space processes is just it's not a good way to get your architecture onto the right foot. But even if you solve that problem, there's actually a bigger one hiding behind it, which is the update rate mismatch problem. This happens when a source of messages generates them faster than the receiver can handle them. And they start to queue up and the receiver falls behind, and the farther behind it gets, the wonkier the system behaves, until eventually you can't save up messages forever. Something's got to give. It crashes. And then the food fight starts within our competitor's engineering team, because the guys that are sending the messages say, hey, you guys got to process those messages faster. And the guys that are responsible for the code on the other side say, we're processing them as fast as we can. You guys have got to throttle back the rate you're sending them. They can't even agree on whose bug it is. And the reason is they're both right. It isn't either of their bug. The bug is in the architecture. Message passing is a flawed construct, so we don't use it. Instead, we use a database. When things change, when the fib changes, when links go up and down, whatever's happening in the box, as those things happen, the process that detects them updates the system database. The system database then propagates the updates to the agents that need to react, to load the new routes into the hardware or whatever. You might be saying at this point, well, what are you talking about? Like if you change the state too fast, the guy can't keep up, you've got the exact same problem. No, that's the beauty of being state-oriented. If one process receiving updates starts to fall behind, our system database automatically coalesces the updates. If a route's next hop changes from A to B to C to D, and the ASIC driver is falling behind, I don't have to send it all 4 of those updates. I can just send it the prefix changes to D. As long as you get into the correct final state, it doesn't matter the path you take to get there. So when somebody's falling behind, we can automatically shed load, coalesce work, reduce the load on these processes falling behind, enable it to keep up with everybody else, and keep the whole system stable. So once routing settles down, the whole thing's running correctly. And I believe that this architectural advantage compared to message passing has been a major benefit for us and our customers when it comes to stability of our equipment under the surprising demanding scenarios when all you-know-what breaks loose in your network and some router is flapping up and down and adding and withdrawing 10,000 routes and adding 10,000 routes and withdrawing them again, and something nutty happens. And nobody can keep up with that kind of churn. But there's a very big difference between doing the best you can until the condition's removed and then resuming normal operation versus crashing, which is what we've seen some of our competitors' boxes do in those kinds of demanding scenarios. The third part of quality is testing. And the way I like to say this is the first rule of quality is get rid of QA. We don't have a QA team at Arista at all, because QA is a fundamentally flawed concept. QA is the lie that you tell yourself that it's possible to say, hey, these guys here, they're responsible for quality. They're the quality assurance team. It's just not true. It doesn't work. These products are too complicated. The software has too many dark corners. The QA team doesn't even know where the dark corners are. And even if they knew where they were, they don't have the tools to drive the software into those corners. In order to actually achieve quality, what you need to do is have each development team be responsible for the quality of their area of the software. That means every feature team owes me 2 things. They owe me the new code, and they owe me a set of automated tests that prove the code works. We've taken a 100% automated approach to testing from the very beginning. And the reason why we did that is actually kind of interesting. It was selfish. It wasn't for our customers. I did it for me as a software person, because I've always been a software guy. I'm a software guy at heart. And if you're a software person, you know that a major requirement in order to create great software is to refactor. Because when you first do a module, you might do a great job. It does everything you need for the first version. But then version 2 shows up. New requirements. Oh, well, I think I can fit that in here and fit that in over there. And it still hangs together pretty well. And you ship. And then comes version 3. It's like, okay, I did not know I was going to need to do that. So at that point, you need to refactor the module. But what happens in some of our competitors' environments is that you try to do that, to refactor the module, and well, let me say this differently. You're trying to do your feature, and you look at the module you're building on, and you're like, it doesn't meet my needs. It doesn't give me the right callbacks. It doesn't give me the right notifications. It doesn't have the right indices to make the right lookups or the right updates fast. Like, how are you supposed to build on this thing? And so you look at other features that are similar to yours, and you find these elaborate workarounds, shadow copies of state, parallel indices, these hacks where you say, well, I care about A, but I only get a callback on B. I know, I'll hook B and set a timer and then start polling A, and oh my God, this is the way you create software that usually works. This is not the way you create software that actually works. So what would happen to you if you try to go and fix this problem, you try to refactor that module, something really interesting happens. You do the work, you refactor the module, you rip out piles of workaround code from other modules, you do your feature, you're feeling great, you go to check this in, you can't check that in. Why not? Well, you know, Ken, that code you just refactored, that's being used by 4 different features on 9 different platforms. Tell me, were you planning to retest all that yourself? Well, of course I can't do all the testing myself, that's crazy, but you know, we're doing a big release here, right? Surely QA is already going to test all this stuff. Well, back when we first developed the feature, or first shipped the platform, yeah, we did full feature test. But you know, for this release, we weren't planning on making any major changes in that area, so we thought we'd just do regression test. Oh, regression test, well, what does that mean? We poke it with a stick, it wiggles, we ship. And customers can tell if there's any problems. You know, and so that leads to my first rule of quality is get rid of QA. My first rule of avoiding regressions is get rid of regression test. I started Arista bound and determined that I, as a software engineer, could refactor any module I wanted on any release I wanted, because our automated test environment would run every test, every case, for every feature, on every platform, for every release. And that's what we've done. We have a data center here, another one across Central Expressway, full of equipment running 24/7, where software decides which branch to build, which testbed to load that build onto, which tests to run on that testbed, runs the tests, puts the results in a database, matches the log against, if the test fails, matches the log against fingerprints of known failures, updates the bug, hey, happened again right over there. Or if not, it goes to an outsourced group to fingerprint and open the bug and dispatch to engineering. This system has effectively eliminated regressions. We've had almost zero. And I wish I could look you in the eye and say we've never had a bug. And that's not true. We've had bugs. But as you go down an Arista maintenance train, the software just gets better. It's not the situation our customers are used to. What they're used to is, hey, the vendor finally has a release that fixes the bug and introduces 5 more, right? So customers are loath to upgrade. And as a result, what I see now is people in the field getting burned by zombies, bugs that we fixed sometimes years earlier, where the customer hasn't upgraded. And so what we're trying to do about that is, first, be able to assure the customer with a straight face, as you go along the maintenance train, it's just getting better. You don't have to recertify every time we fix a bug. Second, make it easier for the customer to tell if they need to upgrade. So we're working on a feature that monitors your installation and figures out which known bugs apply, given the hardware models you have, the software versions they're running, and features that are enabled, and potentially other operating characteristics, and alerts the customer. These 5 bugs are present in your network. Maybe they haven't bitten you yet, but they might. Now would be a very good time to upgrade. Here's a maintenance release that has all those bugs addressed and no new exposures. And then we've got to make it easier, less painful, for customers to actually do the upgrade. Because if you've got a network ops background, trying to update the software on 1,000 switches, it's not a fun task. And that's what we're trying to do with our smart system upgrade, addressing it from 2 points of view. First, not requiring maintenance windows. You can update the software on our switches on a live network. And like Anshul showed, at the leaf, you lose 17 milliseconds. If you're using MLAG or maintenance mode, you lose exactly 0, both on the way down and on the way back up. And then second, automate the process of going switch by switch by switch, taking the switch out of service, updating the software, putting it back into service, and then validating that it's still functioning correctly. It's still doing the same role it was doing prior to the upgrade. If anything looks off, raise your hand and say, could somebody with a carbon-based brain please look at this, because I'm not sure this is going exactly like it should. And then the human operator gets involved and either says, oh, that's fine, that's expected, go to the next switch. Or the human operator says, oh boy, that's not right, roll back. And then we automatically undo the upgrades across the network. So that's what we're doing to try to get our customers' operational experience, which we believe is already far better than competitors in terms of the quality they've experienced, up to the next level, to get them onto the heads of our maintenance trains so we can put an end to zombie bites. And we'll be all of us will be in a much better place.